we now discuss the solution of a problem from the vector algebra, and the problem is on coplanar vectors. This problem has appeared in JEE main examination held on 25th July 2021 in the morning shift. The problem is, let the vectors 2 plus a plus b in brackets I plus a plus 2b plus c j minus b plus c k 1 plus b I plus 2b j minus bk and 2 plus b I plus 2b j plus 1 minus b k, where a, b, c are real numbers, be coplanar, then which of the following is true? 4 options are given to us. Each option is a relation among a, b, c. We now discuss the solution of the problem. We have the given 3 vectors. So these are the 3 given vectors with us. 3 vectors u, v, w are coplanar. That implies the box product of the 3 vectors u, v, w is equal to 0. That is, the scalar triple product of u, v, w is equal to 0. This is a condition for coplanarity which we know. Given that these 3 vectors are coplanar, therefore the box product of these 3 vectors, or the scalar triple product of these 3 vectors, is equal to 0. How do we write scalar triple product of these vectors? We write down the determinant of a 3 by 3 matrix whose first row are the components of the first vector, second row the components of the second vector, third row the components of the third vector. So that implies the determinant of 2 plus a plus b, a plus 2b plus c, minus b minus c. These are the components of the first vector. And similarly, we write down the components of the second and third vectors here. And we will now evaluate this determinant and equate to 0, and we will get a condition on a, b, c. And given that the 3 vectors are coplanar and we have already written the determinant, that is equal to 0. To evaluate this determinant, what we do is, from the first row, subtract the entries of the second row. And from the third row, subtract the entries of the second row. And when you subtract the entries of the second row from the first row, you will get in the first row 2 plus a plus b minus 1 minus b. Minus b out, and 2 minus 1 is 1, 1 plus a. A plus 2b plus c minus 2b, 2b cancels, and a plus c will remain. And minus b minus c minus of minus b plus b minus b cancels, and minus c will remain there. And in the third row, 2 plus b minus 1 plus b, b cancels, and 1 will remain. 2b minus 2b, 0. 1 minus b minus b, that is plus b, cancels, and you will have a 1 there. So you will have 1 plus a plus c, minus c, and the second row remain as it is. The third row is 1, 0, 1. And expanding this determinant by the third row, we get, this is third row and first column. So therefore 1 times, because minus 1 to the power of I plus j, that is 1 plus 3, 4. Therefore it will start with with plus. So 1 times, so delete the first row and first column, you will get a plus c times minus b minus 2b times minus c, and 0 times, no contribution, plus 1 times 1 plus a into 2b minus 1 plus b into a plus c. So multiply, and there are the terms, AB terms are there, minus AB plus 2AB, that cancels, which are shown in green, and minus BC, minus 2BC plus 2BC is there, therefore they cancel off, and you are left with 2B minus A minus C is equal to 0. That will imply 2B is equal to A plus C. Therefore, if the given three vectors are coplanar, then the condition is 2b is equal to a plus c. Let's look at the options, and our answer 2b is equal to a plus c is precisely appearing against the option 2. Therefore, our answer is option 2. So that is the simple and straightforward problem from the vector algebra on the coplanarity, and questions are coming on coplanar vectors, and concentrate on this topic of coplanarity, and I am sure that you have understood the solution of the problem. I wish you all the best. Thank you.